Yeah, what you care though. Good enough. They send the son to when you come. Send something. Yes, yes. The class is about to start. This will be a class you will never regret that you attend. Leaders and champions, welcome to Neotisa, where dreams are made, where the future are made. Welcome to Neotisa, where the future are made. In the next 45 seconds, we are going to start. In the next 45 seconds, we are going to start so that you people, you won't regret attending today's lecture. You won't regret it. You won't regret it. You won't regret it. You won't regret it. Okay. Countdown. We have just 10 seconds left. 10 seconds left. We have 3 seconds left. 3 seconds left. We have 1 second left. Let's start. Leaders and champions, welcome to Neotisa, where the future is made. These are 40 most likely JAMB questions you have to do before you write your JAMB. We are going to take them one after the other. Then I will explain on each question. Then I will give you a kind of bonus that will make today's class to be a class you will never regret. Because all these questions are what gotten from your mock. And there are some that a lot of them, we have them in our question bank, which we want to give to you. You will never regret today's class. Let us start. The atomic number of an element, we are starting with the first question. The atomic number of an element is 17. Atomic number, atomic number, atomic number, atomic number. Don't forget, atomic number is known as proton number. Take note of that. That is first point. Atomic number is known as proton number. Atomic number of an atom is the same thing as what? Proton number. Then when you have an atom is a neutral substance. An atom is a substance in which the proton number and electron number. Take note of that point. Write it down also. In an atom is a neutral substance. In an atom, the proton number and electron number are the same. In an atom, proton number and electron number are the same. And I told you, atomic number is what? Number. Atomic number is proton number. Then for an atom, proton number is the same thing as what? Electron number. Take note of that. Then let's look at the question. The atomic number of element is 17. How many electrons are in its outermost shell? Are in its outermost shell. the number of the electron in the atomic shell of an atom with atomic number of 17. When you have an atom with atomic number of 17, that means the electron number is the same thing as proton number, don't forget. And atomic number is proton number. That means the proton number of the atom will be what? 17. Therefore, the electron number is also what? 17. Then write the electronic configuration, which is 1s2, 2s2, 2p6, 3s2, 3p5. I've done a video on this, which will be what? Posted or downloaded on the channel. You can watch this video on how to write electronic configuration. I've done a video on it. It will be on the YouTube channel. You can see so that you can understand how to write electronic configuration. How to write electronic configuration. Take note of this. This is what the electronic configuration of the Of the atom. The electronic configuration of the atom. That means we have 2 plus 2, 4 plus 6, 10 plus 2, 12 plus 5, 17. That means the electron number is 17. They now say how many electron number are on the atomic shell. What you have to know is this. Look at these 3. This is the last shell. The last shell of the atom. Don't forget, 3 is the highest number here. That means the atom has how many shells? 3 shells. 1, 2, 3. Don't forget about that. You have 2 in 2 places. Forget about that. Now you have 3 in 3 places. In 2 places. Forget about that. This one, atom. This atom has how many shells? 3 shells. 1, 2, 3. 3 shells. Then the last shell is what? 3. That means 3 is the last shell. 3 is the last shell. Then how many electrons are on the last shell? 2 plus 5, 7. That means the option is what? D. Now, look at this. How many shells does it have? 1, 2, 3. 3 shells. Then the 3 shell is the third shell, is the last shell. How many electrons are on the third shell? 7. Take note of that. Question number 2. Which of the following has the smallest atomic radius? Which of the has the smallest atomic radius? Let me quickly explain this. Atomic radius. We have properties of periodic table. Properties of periodic table. Or periodicity. The properties of periodic table, which are atomic. We have atomic radius. We have ionization energy. We have electron affinity. We have electronegativity. We have it. Take note. As you are moving from left to right across the periodic table, as you are moving across the periodic table, atomic radius decreases. While the other 4, this other 3 rather, ionization energy, electronegativity, electron affinity, they what? Increases. Let me explain. As you are moving across the periodic table, please write this down. We have 4 of them: atomic radius, ionization energy, electron affinity, electronegativity. Let me quickly draw the periodic table. When you have the periodic table like this, hydrogen, lithium, sodium, potassium, beryllium, magnesium, calcium, boron, aluminium, carbon, silicon, nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine, helium, neon, argon. That is when you have these. This is what periodic table of the first 20th element. The first 20th. The first 20 element. The first 20. The first 20 element. The first 20 element. Group 1, group 2, group 3, 4, 5, group 6, group 7, group 8. Take note, as you are moving from left to right, that is across the period. Across the period, you are moving from left to right. Moving from left to right. Take note, atomic radius decreases, while ionization energy, electronegativity, electron affinity increases. Write it down. It's only atomic radius that decreases, but we have some anomalies. In there, which I will do a video on it, especially for the JAMB students. For the JAMB students, because under atomic radius, we have covalent, we have van der Waals radius, we have metallic radius. Take note of that. Take note of that. I will do a video on them. We have ionic radius. I will do a video on them. Then under electron affinity, I will do a the element that has the highest electron affinity is what? Chlorine. Take note. Chlorine. Write it down somewhere. Chlorine has the highest electron affinity. Chlorine has the highest electron affinity. While fluorine is the most electronegative element. Fluorine, most electronegative element. Then chlorine, highest electron affinity. Chlorine, highest electron affinity. I will explain in a video. But take note, in JAMB, take note, as you are moving from left to right, the highest, that is from left to right, atomic radius decreases. Ionization energy, electronegativity, electron affinity increases from left to right. Then as you are coming down the groove, what happens? Atomic radius increases, while the other three decreases. Take note of that. Hope that you've written this. Then let me write it here. Please, there's no space. That's all. Let me clean this one. Let me clean this one. Because I've answered this. Coming down the groove from top toward bottom to bottom. What happened? Atomic radius increases, while ionization energy, electron affinity, and what? Electronegativity decreases. Take note of that. As you are moving from left to right, atomic radius decreases, ionization energy, electronegativity, electron affinity increases. As you are coming from top to bottom, atomic radius increases. Ionization energy, electron affinity, electronegativity what? Decreases. Then let us answer this question. Which of the following has the smallest atomic radius? We have sodium, magnesium, aluminium, silicon. Look at it. Sodium, magnesium, aluminium, silicon. As you are moving from left to right, what happens to atomic radius? It decreases. As you are moving from left to right, atomic radius decreases. Therefore, the one that has the lowest atomic radius is what? Silicon. Option D, silicon. Take note of that. Option D, silicon. Please, take note. A video will be done on that so that you can watch it over. Please take note of that. Let's move to number 3 rather. Number 3. An element has mass number 40 and atomic number 18. How many neutrons does it have? 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 Please, you can watch the video over, pause it. Please, let me rub this one because of time. Because of time. Because of time. Please take note of that. Please take note of that. Take note. Take note of that. Because of time, I was told that I spent 16 minutes. An atom X has mass number of 40. Atom X, take note, mass number on top 40. An atomic number 18. Atomic number is 18. Atomic number is 18. And I told you atomic number is a proton number. Take note of that. Take note. This is what mass number. Mass number. Then the question is, how many neutrons does it have? Don't forget, mass number equal to proton number plus neutron number. Take note of that. And take note of this. Take note of this. Take note of it. Neutron is heavier than proton. Among those 3 substances, in what? In an atom. Proton and neutron, they can be found in what? In the nucleus of an atom. Proton and neutron can be found in the nucleus of an atom. Proton and neutron can be found in the nucleus of an atom. This proton and what? Neutron are in nucleus of an atom. And 2 of them are called nucleons. They are called nucleons. And the force that occurs between proton and nucleus is nuclear force. Nuclear force. Take note. This neutron is the heaviest. Is heavier than what? Proton. Take note of that. Then you know this mass number equal to proton number plus neutron number. What is mass number? 40. Proton number is atomic number 18 plus neutron number X. Then you have 40 minus 18 equal to S. Therefore, S is what? Is what? 22. That is proton number is what? 22. Option C. Let's move. Let's move. Let me take water. Don't worry. Don't worry. You will learn so many things in this question. In the next 1 hour. Water is life. Let's move. Let's move. Number 4. Number 4. Number 4. Number 4. Number 4. The question is, which of the following elements belongs to group 7 of the periodic table? I've drawn the periodic table for you. You should know the first 20th element. Group 7 is what? Is chlorine. Group 7. It has 7 electrons on the outermost shell. It has 7 electrons on the outermost shell. Group 7. Number 5. We have isotope of element. How they say, let me quickly explain this. You will see question on isotope, isotone, isobar. What is isotope? Isotopes. When you have atoms of the same element, having different mass number, but the same atomic number. Write it down. Atoms, or I said the same element. Atoms of the same element having different mass number, but the same atomic number. Don't forget, when I told you this in the second question, where you are 40, 18, I told you this is mass number, this is what? Atomic number. And I told you atomic number is the same thing as what? Proton number. Then for isotope, the mass number is not the same, but the atomic number or proton number are the same. Isotope, they have the same proton number, the same atomic number, but their mass number is not the same, and they are of the same element. What do they mean? For example, when you have hydrogen 1 1, hydrogen 2 1, hydrogen 3 1. These are three isotopes of hydrogen. That is the same element, atoms of the same element. Which element? Hydrogen. Atoms of the same element, hydrogen, with different mass number. Mass number is the one on top. Mass number is the one on top, but the same atomic number. But the same atomic number, 1 1 1. The same proton number. Atomic number is proton number. That is isotope. When you have atoms of the same element having different mass number, the same atomic number or proton number. The name of this one is what? Normal hydrogen. Protein. The number hydrogen. The one of deuterium. Heavy hydrogen. The symbol is D. It's called heavy hydrogen. Heavy hydrogen. It is used in production of heavy water. And this one is called tritium. That means radioactive hydrogen. Radioactive hydrogen. These are the three isotopes of hydrogen. That is isotope. They have the same atomic number, different mass number. That is isotope. What is isobar? In the case of isobar, when you have argon 4018, calcium 4020. For isobar, they have the same mass number, different atomic number. Isotope, the same atomic number, different mass number. Isobar, mass number, different atomic number. That is isobar. Take note. Isobar, the same mass number, different atomic number or proton number. Isobar. Then we have, this is isobar, the same mass number, different atomic number. That means, as this is an example, mass number are the same, atomic number are different, or proton number. But this one, the same proton number, or atomic number, different mass number. Then we have isotope. This one, they have different neutron number. Their neutron number is not the same. The neutron number is not the same. Their neutron number is not the same. That means isotope. Take note. Then look at it. Isotope of an element has the same mass number, neutron number, atomic number, physical property. The answer is what? They have the same one, atomic number. C. Number 6. Let's look at number 6. Number 6. Hey, excuse me. If you see me screaming. Okay, number 6. What is number 6? The electronic configuration of calcium ion. Electronic configuration of calcium ion. Class, take note. When you see a positively charged substance, that substance is lacking electron. When you see a negatively charged substance, that substance is having excess electron. I repeat, when you see a positively charged substance, that substance is what? Lacking electron. When you see a negatively charged substance, that substance is what? Having excess electron. Look at this. Calcium ion. That means it's lacking electron. That means when you have calcium atom, and don't forget, calcium atom has atomic number for 20. Because it is an atom, the proton number is also 20. Atomic number is the same thing as proton number, 20. Then the electron number of an atom is the same thing as proton number of the atom. Calcium atom, atomic number 20. That is proton number 20. Because it is an atom, the electron number is the same thing as the proton number. Electron number is also what? 20. Then this calcium atom has 2 electrons on the atomless shell. It can be found in group 2 from the periodic table I drew. It can be found in group 2. If you can go back to that periodic table, there you have hydrogen, lithium, sodium, potassium, beryllium, magnesium, calcium, boron, aluminium, carbon, silicon, nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine, helium, neon, argon. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Atomic number 20. That means electron number 20. He has 2 electrons, group 1, group 2. That's why it can be found in group 2. Group 2 element, they have 2 electrons. Atomic shell. Group 3 electrons on the atomic shell. Take note of that. Then he has 2 electrons on the atomic shell. For it to be stable, it must obey octet rule. What is stability? Another thing. Stability. Can you see? Stability. That means duplex rule and what? Octet rule. That is stability. And the only element that form duplet is what? Helium. Helium. Then all the other elements in group A. Helium, neon, argon, triton, xenon, radon, organism. All these elements in group A, apart from helium, all these one from year to year, they form octets. But helium form what? Duplets. Take note, helium form duplet. Helium form duplet. But neon, argon, triton, xenon, radon, organism, they form what? Octet. That stability is duplet and octet. Duplet is for helium. Why? Because it has its 2 electrons on K shell, and K shell can take maximum electron of 2. And this hydrogen can also form duplets. To be stable. That's stability. Then this calcium, for it to be stable, it must have 8, but it has 2. What it can do is to lose 2 electrons. To lose how many electrons? 2. Here, it has 20 electrons. Atomic number 20, electron number 20, because it's an atom. He now lost 2 electrons. Positive means losing. When you see negative, that is gaining. That is oxygen gain 2 electrons. Positive means what? Losing. Calcium lost how many electrons? 2. Therefore, the electron number will change from 20 to what? 18. This one has 18 electrons now. But this one has 20 electrons before. This one has 18 electrons. Then draw the atomic electron configuration of this, of 18 electrons. 1s2, 2s2, 2p6, 3s2, 3p6. That is 18. That was the answer. Take note of that. Take note. Option what? In the answer, in the question below, it is option. That is question what? Question 6. Option what? Option B. Option B. Option B. Let's move. Next question. Which quantum number determines the shape of an orbital? I've done a video on this too. It will be posted. We have 4 quantum numbers. Let me quickly explain in the next 3 minutes. Quantum number. How many quantum numbers do we have? 4. We have principal quantum number, which symbol is N. We have azimuthal quantum number, which is also known as angular momentum, or subsidiary quantum number. Take note, the symbol is small letter L. Take note, we have This first one, second one. Third one, we have magnetic quantum number. That means the symbol is what? L, subscript of L. We have spin quantum number. Please take note. The symbol for this one is what? NS. Take note. This one, let me quickly explain what they do. This one determines the size of shell, determines energy level. Principal, quickly write it down. Determines the size of shell, energy level. K, L, M, N. The first energy level, second energy level, third energy level, fourth energy level. That means the first shell, second shell, third shell, fourth shell. Take note. Take note of that. Take note of that. First energy level, second energy level, third energy level, fourth energy level. First shell, second shell. That means it talks about energy level. Energy level means shell. Take note. This one, azimuth, this one, which is also called what? Angular momentum or subsidiary quantum number. Take note. It determines the shape of orbital. Determines the shape of orbital. Quickly write it down. Determines the shape of orbital. Determines the shape of what? Orbital. That is one. Determines the shape of orbital. Shell. It divides. Quickly write it down. Azimuth quantum number. Determines the shape of orbital. It determines the shape of what? Orbital. And divides shell toward orbital. It determines the shape of orbital and divides shell toward orbital. Take note. Take note of that. We have S, P, D, N. The shape of this is what? Spherical in shape. Shape of this, spherical in shape. Spherical in shape. The shape of this is what? Dumbbell in shape. Shape of this one is what? Double dumbbell. Shape of this is what? Complex in shape or segment. Complex in shape. Quickly write it out. That is azimuth. Magnetic. It talks about orientation of orbital in space, the orientation. While this one talks about the position of an electron in what? Orbital. We have just two direction. Clockwise movement, anti-clockwise movement. Take note of that. Then the question is, we have quantum number determines the shape of an orbital. The answer is what? Azimuth quantum number. That is option what in the question? Because you people have gotten the question, or the PDF of the question we sent to you will be on the what? The comment section. People on the WhatsApp group, you've gotten the what? The question before. The answer to that question is what? Azimuth. That is option D. Let's go. Number 9. How many minutes left? How many minutes? Let me know. I'm seeing it's 26 left. Okay, let me use, because I want to give you some bonuses before. Okay, let me know. Okay, the next one. An element in period 3 and group 7A is what? Period 3. An element in period 3 and group 7A. That means when you have hydrogen, lithium, sodium. Period 3. Sodium, potassium, beryllium, magnesium, calcium. I need to draw scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, tin, then boron, aluminium, gallium. I need to draw that. But take note, from that periodic table, where you have hydrogen, lithium, sodium, potassium, beryllium, magnesium, calcium, boron, aluminium, carbon, silicon, nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine, helium, neon, argon. They say period 3. Period is horizontal arrangement. This is period 1. We have just 2 elements in period 1. This is for period 2. This is period 3. period 3, period 3. This is period 3, period 3. Then group was 7, group 2A, group 2A, group 1, group 2. That is group, this is group 2, group 2. Then period 3, group 2, period 3, group 2. That is what magnesium. Don't forget, calcium is in what, period 3. Well, period 4 rather. Calcium is in period 4. We say period 3, then group 2, that is magnesium. The answer to that question, magnesium. That is option what? Option, I didn't write the option yet. You know the option in the question on your hand with you. Let's move. How many lone pair of electrons does water molecule have? Listen to this one. Listen to this one. How many lone pair of electrons does water molecule have? We have what we call lone pair electron. We have what we call unpaired electron. We have what we call shared pair electron or shared covalent electron. We have what we call electron. We have what we call valence electron. Let's explain it. Valence electron is the electron on the atom shell. For example, when you have chlorine, let me say oxygen, 2, let me say 2, okay, let me say sodium, for example, sodium, 1, this is sodium. This is valence electron, the electron on the atom shell. For sodium is 1, for calcium is 2. If I have for aluminium 3, for carbon 4, you can find before. The number of electrons on the atom shell is called valence electron. Core electron they are called inner electron. These are core electron. This one, and this one. They are inner electron, core electron. We have unpaired electron. That means electron that is not paired, that is the only one standing. Like this one now, they are unpaired. If you have an orbital, for example, an orbital, let me say p orbital, and you have these are unpaired electrons. We have 3 unpaired electrons. Unpaired, they are standing alone. Then we have lone pair electron. When you have something like this, these are lone pair. 2 means pair, lone pair electron. But they are not shared. They don't partake in what? Bonding. They don't partake in chemical bonding. Then we have shared covalent electron. Those ones that involve in what? Covalent bond. That involve in covalent. What is covalent bond? That is sharing of what? Electron. Sharing of electron between metals and sharing of electron between non-metals. Covalent bond. That means when you are sharing of electron between what? Between non-metals. Covalent bond occur when non-metals combine with non-metals. Sharing of electron between non-metals. Those electrons that are shared are called shared pair electron or shared covalent electron. Take note of that. They say in water, how many lone pairs do we have? What we do, very simple. This is the trick. H2O. We have hydrogen 2, oxygen 1. What is valence electron of hydrogen? Valence electron. That means how many electrons are on the atom shell of hydrogen? 1. Atom shell of hydrogen, it has 1 electron. Then how many electrons? How many hydrogen do we have? 1. 2. That means here 2. That means 1 times 2. That means valence electron. Use the valence electron. Use the valence electron. That means for hydrogen, the valence electron of hydrogen is 1. How many hydrogen? 2. 1 times 2. That means we have 2. Therefore, oxygen. What is valence electron of oxygen? Oxygen has 6 electrons on the atom shell. The valence electron of oxygen is 6. That means, and how many oxygen do I have? 1. That means 1 times 6. That is 6. In total, how many valence electrons in total? 8. 8. Then we have oxygen, hydrogen. This one, single bond means 2 electrons, 1, 2. Another single bond means for 2 electrons, that means 1, 2, 3, 4, making 4 electrons. Out of 8, 4 has gone. Remaining one, 4, 5, 6, 7, 8. That's how to do it. That means here, how many lone pair? The one that this one now is for shared pair, because the electron are shared between oxygen and hydrogen, which are 2 electrons, 1, 2, 3, 4. These are shared pairs electrons. They are shared between oxygen and hydrogen, oxygen and what? Hydrogen. Shared pair. Then how many lone pair? 1, 2. In water, how many lone pair? 2 electrons. 2 lone pair electrons. Lone pair. Take note. 2 lone pair. Or you can just do this. When you have hydrogen 2, you have hydrogen 2. That means you must have shared. Then you have the remaining one. You have 2 lone pair. Then, for example, if they say ammonia, the answer to that question is 2. Take note. 2 lone pair. 2 lone pair. The one that is not partaking in what? In bond 1, 2. Take note. For example, when you have this, let me use ammonia. For example, ammonia. If they ask you how many lone pair are there in ammonia, what do you do? You have hydrogen and nitrogen. The valence electron of hydrogen is 1. He has 1 electron on the atom shell. How many hydrogen? 3. That is 1 times 3 equal to 3. In nitrogen, how many valence electron? 5. You can find in group 5. You have 5 electrons on the atom shell. That is 1 times 5. Nitrogen is 1. Then times the valence electron. Hydrogen is 1 valence. Then times how many hydrogen? 3. Then nitrogen valence electron 5. How many nitrogen? 1. Valence electron of hydrogen is 1. How many hydrogen? 3. Valence electron of nitrogen is 5. How many hydrogen? 1. Yeah, that means we have 5. In total, 8 valence electron. 8 valence electron. That means we now have nitrogen. 3 hydrogen. 2 here. Another 2 here. Another 2 here. Remaining 1, 2. How many lone pair? 1. How many shared pair? 1, 2, 3. In water, how many lone pair? 1, 2. How many shared pair? 1, 2. 2 shared pair in water. 2 of that. Please take note of that. Let's move. How many minutes left? 15. Okay, let's move. Next one. Which of the following has linear shape? Let me quickly give you this. Linear shape. Linear shape. What is the shape of water? The shape of water is of belt. Take note. Or V shape. The shape of ammonia is trigonal pyramidal. The shape of methane, let me say alkane, methane, tetrahedral. The shape of CO2, chlorine gas, oxygen gas, hydrogen gas are linear in shape. The shape of alkene, trigonal planar. In JAMB, I will explain this one better. The shape of alkane is what? Linear also. Alkane is linear. Take note. Therefore, which one has linear shape? The answer is what? CO2. That is question what? 11. The option is what? C. Take note of that. And I can quickly give you their bond angle. Okay, let me quickly give you their bond angle. Bond angle. Take note. The bond angle of this is what? 104.5 degree. Take note. They will ask you, JAMB student. The bond angle of this one is what? 107 degree. Bond angle of K is what? 109.5 degree. Bond angle of linear, when you hear linear, that is 180 degree. Bond angle is 180. Take note. Bond angle is 180 degree. Trigonal pyramidal, which is alkene, bond angle is what? 120 degree. Alkyne linear, 180 degree. Take note of that. Hybridization, let me write this here. Hybridization. They can ask you their hybridization. Hybridization of water, sp3. Hybridization of this one too, sp3. Hybridization of alkane, sp3. Hybridization of alkene, sp2. Alkyne, sp. CO2 hybridization is sp also. CO2 hybridization sp. Take note of that. Take note of that. Let's move to the next one. A dative bond is formed when a dative bond. Another name for dative bond is what? Coordinate bond. Coordinate bond. It is formed when one atom donates both electrons. Yes, B. When one atom donates both electrons. And that is the kind of bond that occurs in what? Coordination compound. Coordination compound. It's a kind of bond that occurs in coordination compound. That is when you have transition metals. Don't forget, transition metals can exhibit what? Dative bond. Dative bond. When they combine with Lingard. I've done a video on that. It will be posted. Don't worry. Which of the following is a good conductor of electricity? The answer is for copper. Copper. Why? Because it's a metal. It exhibits metallic bond. Metallic bond. And metallic bond occur when there's free delocalized electron. I've explained that in a video. We have all those videos. It will be posted. Please, it will be posted. Metallic bond occur when there's what? The free delocalized electron exhibit the force between free delocalized electron and what? Metallic ion. When the force between them is what? Electrostatic force, you have metallic bond. And metals can conduct current by what? The current carrier known as electron. Electrons are the current carriers in metal. If they say in semiconductor, what are the current carriers in semiconductor? Semiconductor exhibit covalent bond. Semiconductor exhibit covalent bond. The current carriers in semiconductors are holes and electron. But which are silicon and germanium? They are example of pure semiconductor. But in copper, which is metal, the current carrier is what? Electron. Take note of that. Take note of that. That means the current carrier is free delocalized electron because it exhibits metallic bond. Next one, question 15. That is question 14. We have question 14. The bond angle in methane. The bond angle in methane. I've given you that. The bond angle in methane is what? This. 109.5. Question 15. I will stop at 15 before I give you a kind of bonus I want to give you. You need how many minutes left? 10. Okay. I will give you question 15. They say, what is the molar mass of H2SO4? What is the molar mass? What is the molar mass of H2SO4? Molar mass of H2SO4. When hydrogen is 1, sulfur is 32, oxygen is 16. Molar mass. Molar mass is the addition of the sum of their what? Mass number. Hydrogen is 1. How many hydrogen do you have? 2. Plus sulfur, 32. How many sulfur? 1. That is plus 32. Plus oxygen, 16. How many oxygen? 4. Plus 16 times 4. Then you can do the mathematics. 2. 1 times 2, 2. plus 32 plus 16 times 4 will give you what? 64. 64. Then you can do the sum. That is your answer. Please. Then, what are the bonuses? That is, do the sum yourself. What are the bonuses that I want to give you? The bonuses I want to give you, very important. Very important. Right. Production of compounds. Some processes we use. Production of some compound. They will ask you, which compound do we use other process to produce? Which compound do we use sulfate process to produce? Which substance do we use Gibbs apparatus to produce? Which substance do we use Castina Kerner to produce? Which substance do we use Oswald process? That one came out last year. It came out 2023. It came out last year. Oswald process to produce. Which substance do we use what? Bosch process to produce. Which substance do we use this? They will ask you. They will ask you. Let me give you. The first one, other process. Other process. We use it to produce what? Ammonia. And the catalyst, the processes, the process, the compound, and catalyst that is used in that process. The catalyst used in this one is what? Ion. Write it down. Please, write it down. Very important. Very important. Very important. We have contact process. Ammonia. You should be able to, by this time, you should be able to ammonia. Because my technical graduate, right, you should be able to know the JAMB student now. Ammonia. We have contact process. Contact process. We use to produce H2SO4, SO3, contact process. I can say onion, that is onion. And the catalyst uses of vanadium 5-oxide. That is the catalyst used in contact process. The next one, Oswald process. We use it to produce nitric acid. This one, take note. Nitric acid. Oswald process. Nitric acid. And what is the catalyst used? We have platinum, rhodium catalyst. Oswald process. We have Solvay process. We use it to produce our sodium triosocarbonate 5. Sodium carbonate. This one does not require any catalyst. We have Castina Kerner. Take note of this one. Castina Kerner. We use it to produce sodium hydroxide during electrolysis process. Castina Kerner. We use it to produce sodium hydroxide. In this one, no catalyst required. Castina Kerner. We have digging process. For those of you that go to church, digging process. We use it to produce chlorine gas. Digging process. And the catalyst used in that process is what? Copper 2 chloride. This is a bonus. You can't see it anywhere. You can only see it in what? Neotisa. Please, if you want to learn data processing, software development, machine learning, AI, please try to contact us. We are building a platform, and that is what we are going to be using as from next year. We won't be using YouTube anymore. Our educational app, mobile app, will be out soon. And who are those people coding it, building it? We. and my partner, shall we? We are the software engineer behind it. We are the software engineer behind it. We are not giving it out. And we are also teachers. We teach chemistry, physics, math. We simplify everything. And we are also what? Software what? Engineer. We are the one building it. It will be out. If you want to learn software development, if you want to learn cyber security, UI, UX, data security, data analysis, please don't hesitate to join us to give you the best. We are going to give you the best. Please subscribe, share this video. Please share this video. Please let us move. We have KIPS apparatus. KIPS apparatus. This one is what? Laboratory preparation apparatus. KIPS apparatus is laboratory preparation of CO2 and H2S. No catalyst involved. KIPS apparatus, laboratory preparation of CO2 and H2S. Don't forget, CO2 is used in what? In beverages. Like your Coca-Cola, your soft drink. That sound, when that gas that produces a pop sound, when you open your beverage, maybe your Coca-Cola, maybe your Big Cola, when you open it, that gas that produces a pop sound is for CO2. In lab, we use KIPS apparatus to produce it and what? H2S. Take note of that. We have Bosch process. Bosch process. Let me rub up this one because I have few minutes left. Bosch process. That one is what? Hydrogen gas. With chromium as what? Catalyst. We use chromium as what? Catalyst. Then let's quickly go to extraction of metals, which is the last one. In the next 5 minutes, I will be out of here. Extraction in the next 5 minutes. Just my technical crew is saying, no time. But I'm begging for 5 minutes so that I don't want to carry this one over. I want to give you everything. Extraction now. For extraction. Okay, let me. Extraction. The process, the substance that's been extracted, it could be what? Metal or non-metal. Then catalyst, if catalyst is involved. We have the first one. We have, French process. This one is used for sulfur, to extract sulfur. Take note of this French process. It's used to what? Extract sulfur. It's used to extract sulfur. We have down cell. It's used to extract sodium from it all. Is used to extract sodium. Down cell. We have down cell also to extract potassium. Down cell also to extract potassium. We have door process to extract magnesium. To extract magnesium. Door process to extract magnesium. We have Bayer process. This one is to purify bauxite into alumina, which is aluminum oxide. To purify bauxite into alumina, which is aluminium oxide. This one is to purify. Bayern process is to purify what? Don't forget, bauxite is what? Ore of aluminium. Let me write this on. Let me write that. Bauxite is ore of aluminium. Then when you have crude bauxite, to purify crude bauxite is used to purify what? Crude bauxite into alumina. Then we have all rods process. This one is now what? To extract aluminium. From alumina. What is alumina? This one, purified bauxite. This is alumina, which is what? Purified bauxite. Using electrolysis process. Take note. The Bayern process is to purify the crude bauxite into alumina. Then all iron is now to extract the what? Aluminium and the what? Electrolysis process from what? The purified what? Bauxite. That means from the alumina, which is purified bauxite. Many, but because of time, I will stop here. Those are the bonuses I will be given to you. Then we have some questions that also came out in the month, like what is what? Aqua what? Regia. We have Aqua Fortis. We have so many of them like that, which we are going to be giving you here. The only place you can get it is what? From Neotisa. Please subscribe to our YouTube channel. Please don't forget to share it with your friend. Comment. Then if you want to learn anything that has to do with our technical skill, please don't forget to contact us. Please, we have our number on our YouTube channel. Don't forget. Look at the way we teach. Then imagine us building mobile app into what? Imagine us that we are into what technical space, and imagine what will happen. Why teaching you what? Those technical skills. Imagine we are the one that are building the mobile app ourselves. We are not giving it to any engineer. Maybe when the money comes, we can now have what engineer. But at this moment, at this beginning, at this starting point, we are not building it ourselves. Please don't forget, I remain myself, JAMB. May God bless you. Thank you.